Many thanks, and thanks for the introduction, and good afternoon to all. What I like to convince you in these 15-20 minutes is that we need really to create a very strong community. I have not to convince you what is the importance of electrocatalysis. Myself, I'm also working on electrocatalysis, but this is not enough, and especially we need really to create a condition in which we can accelerate the research in this area, and a strong community around this aspect is one of the key elements. My name is Gabriele Centi. I'm one of the members of the SunEnergy board. I will first shortly introduce you what is SunEnergy, because maybe that not all you know very well what is. SunEnergy is a large initiative that was deriving before from two applications, Sunrise and Energy X, that was selected to create an European flagship on the topics, let me say in general, on solar fuels. However, in the new Horizon Europe program was cancelled the possibility to have flagship. So what we are now building by merging and going beyond also these two initiatives to create the condition to have in around 2024 a partnership dedicated to this aspect. So we are now in a kind of ramp phase in which we are trying to create a condition, but is already an initiative which is working, and I will try to present you some of the activity that we have made. Essentially, around the main concept around SunEnergy is that we are trying to create the kind of landscape of technology, disruptive technology, which is needed to pass from the actual system based on fossil fuel to the new system based on renewable energy and conventional small molecules. Of course, between the element is storage of renewable energy, production of fossil fuel-free best chemicals, technology with negative carbon dioxide footprint. Is organized in various aspects. There is a coordinator and a deputy coordinator. Coordinator is Bert Verkuisen, and a deputy coordinator is Frederick Chandelon. We have an executive board, we have also an industrial board and a coordination office, and the main activity are related to advocacy, funding, communication, and especially we are building now a strategic research and innovation agenda. The community is really large. We have many supporters. We have already 75 supporting institutions that has signed a specific a letter of support, but the community is larger and we involve many people in our initiative. You see here, for example, we have organized a series of industrial webinars, other workshop dedicated, for example, to specific community in Netherlands, in France, in Poland, and so on. We have a newsletter and many other communication activity. This is one of the output. For example, we have a strong interaction with the community to try to launch and to push some specific topics which are related to general field of solar fuel, and you see that we have also specific call that was introduced in the program that will start in nearly 1 month. One of these is, for example, new electrochemical conversion route for the production of chemical and materials. So what we are trying to push is really to push all these topics, and clearly electrocatalysis is one of the important elements in all this landscape. You see, this morning also something similar. Of course, we are working on concepts that are in some way shared by the community at large, on the concept of a refinery, on the concept of transformation of the production using small molecules, combining electro and photocatalysis with thermal catalysis. You see this morning a very similar presentation, and of course to make this as the building block to make all the chemical and fuels that we need. And clearly, electrocatalysis is at the core of the SunEnergy initiative and action. The reason is very simple, because if we can try to simplify, we have essentially four main possibilities in which we can integrate renewable energy in chemical production. Plasma in combination with catalysis, microwave, photocatalysis, and electrocatalysis, of course, in the various combinations, perhaps combined also with photocatalysis. All the technology are probably will be implemented in the future. They are suited also for small size distributed device, and this is one of the key elements. What we see for the future is that all this technology will completely change the system, moving from the actual very centralized production to a very distributed system. And for this reason, all technology related to electrocatalysis are very important. So they will not only create a new technology which bypass the use of fossil fuel, but create really a completely change in the type of model of economic development, with the regional and district level as a core element for the production, avoiding and of course also all aspects related to circular economy. If we are looking to these different options, as I mentioned, probably they will be all important for the future, but what we can really see is that electrocatalysis probably is the most advanced between these, and probably the more closer to application. And probably also this afternoon later we will see some example of activity exactly to try to bridge and to arrive to commercialization of these projects. It's clearly that one key element in all this picture is that we need to change from a linear to a circular economy. I have not to explain you what is the linear model, but essentially we use fossil fuel and we have carbon dioxide emission. I include in this model of linear also the possibility that even if we have storage of carbon dioxide, we are not changing this model. And this is not really sustainable. We need to pass to a more circular model of production in which we circulate carbon. We need to close the carbon cycle. And of course, we have an initial intermediate steps in which we have thermochemical process as a bridge technology and transition technology with a reduction in the use of fossil and emission of carbon dioxide. But we need to arrive to a full circular economy in which clearly the concept of a refinery that was also presented this morning is, together with other like the one of artificial leaves, are the real key element to arrive to implement this concept of full economy. But a refinery is also something which is more than just this. We have seen this morning also that in the concept of a refinery, we have a series of implementation, carbon dioxide, water, nitrogen, for example, which give, for example, hydrogen, ammonia, or some of the product of carbon dioxide reduction. However, we have a really great potential if we implement this together with the transformation also of biomass and bio-based molecules, and especially we will able to use the active intermediate which are formed in the process of converting. For example, We produce probably radical or activate hydroxyl species, which can be very useful if we can use these in conversion, for example, with some bio-based molecules. I give you just an example. We can directly form phenol from essentially from benzene and water. Clearly, we are still very far from these. We have some intermediate, some advanced in these. We need to explore all these full range of possibility. Maybe in a transition also or with some thermal electrocatalytic transformation to really arrive to substitute the full range of products which are formed today from oil to make these based essentially on small molecules, biomass, and renewable electrical energy. It's clearly a change, a drastic change, and we still are far from these, but this is really the challenges that we have. So we have a radical system transition to form a new energy, and we need to discover many of the new technology and the possibility that we have. This is just only limited from our imagination. And what is important, and this is a message for the company, is obvious that is a transformation which is completely changed the system. And so all the company need really to look to this, revising the model of analyze also the data, because if you apply simple technical, normal, techno-economical approach, is very difficult in this phase. When you have a strong transformation, you can have good indication. So this is the reason why you need to use new methodology, and why for this reason you need to have a strong community, because you need to develop also fundamental aspects which are very important, because it's not just the extrapolation of the current methodology, but you need to develop new methodology. So is really the sharing between community, all the community, and all the stakeholders from industrial to academic and the research institution, which can make faster this transition. This is the reason why we need to change. We need to go to a kind of solar-based economy, and clearly with electrocatalysis is one of the key elements. But the point is that in this process, we need also to reinvent part of the catalysis. I call this reactive catalysis. Just
Gabriele, I just need to comment, you just muted yourself, so it's difficult to hear you. Yes, now
sorry,
but then your slides are gone. So maybe
okay.
You can
when was muted?
Yeah, so you was muted for a few seconds, but now you're back.
Okay. Sorry, I don't know why was happened. So essentially, the concept that I was saying is that
but your slides are not on the screen anymore. So if you can reshare your presentation once more, then I think we are.
Sorry for technical problem.
No problem. Yeah.
Okay. So the concept that I was trying to say is that thermal catalysis that was clearly at the key in fossil fuel and also in bio-based economy is not longer enough to address the problem. When we speak of photo, electro, and other catalysis, we have a completely new kind of catalysis, and we need to develop all the new approach that are needed to go in this direction. So I will skip some of the element, but essentially the concept is that due to the fact that we have very reactive species which are generated by ether, photo, electron, or plasma catalysis, the design and the development of and understanding also of the catalyst cannot be just a classical one that we have, which is based on extrapolation essentially of thermal catalysis. So we need to really have a kind of paradigm shift in the development of the catalyst. And this is the reason why we need to have a strong community. We have many possibilities. I will just very briefly mention some elements just to give you in a little provocative way why we need to go in this way. But between these, we have many, from process intensification to creation of really new process and groundbreaking catalyst development. Sorry. I give you just one example, which is ammonia synthesis. I need not to convince you that is really a breakthrough reaction. If one can achieve, we can have really a very drastic process intensification, drastic reduction in the carbon footprint, more than 90%, and so on. However, what is the current approach? The current approach is largely based on extrapolation of the concept that we have based on thermal catalysis to electrocatalysis, and try to understand and to develop a new system based on this. I just give you here few examples of the many idea and proposition which are on the mechanism. Here you see, for example, the role of doping. These are carbon-based material, the role of boron, phosphorus, or nickel, or iron, molybdenum species, and so on. So any of these methods are supported normally. This attribution based on theoretical method and many classical systems. However, the problem, if we are looking a bit more far from these results, what you see, this is clearly is just a selection of few of them. What you see is that all the results are more or less in a very narrow range of properties. These are specific current density of ammonia formation, again, Faraday efficiency. There are also some better results, but this is not important. And you see here that you have a very large range of possible interpretation in terms of mechanism, but you see that all are very far from the range of industrial interest. So to really to bridge this gap, and to really move from the actual results to those of industrial development, what we need is to have really a different approach. So we need not to just have an extension of the current system, mechanicistic system and other characterization, but really to try to address and to understand why electrocatalysis is not catalysis in presence of electrons or of a potential. And of course, we have many. Here I just mentioned some of the elements. We have, of course, different in terms of adsorbate, in terms of dynamics, in terms of deviation from modality, and so on. So it's not the point here to enter in detail, but essentially, many of these aspects which are different, they are not accounted in or in the current approach, and this is one of the reasons why current modeling approach are still unable to describe this situation. And we need to include many aspects from the fact that exists a potential, an interface with very reactive species, a non-uniform charge distribution in a nanostructural materials, and so on. So we have many aspects which are still not able to understand and to explain correctly. So essentially, the message is that we have a system change. We are changing all our system. We need to have a radical new approach, also theoretical, also fundamental point of view, to describe correctly and especially to accelerate the process. We cannot just base the need that we have on, let me say, classical testing system. We need to accelerate the process. Electrocatalysis is really a key aspect in this process, but we need to address also the complexity which is needed really to transform these from the current technology to the new which are needed to address this system change. So, and for this reason, we need to have a strong community that work together in synergy to really go in this direction. And SunEnergy is one of these actions. Thanks for attention.
Thanks, Gabriele, for this nice overview of the viewpoint from SunEnergy point of view. And also thanks to be quite nice in time. It's not a given for every speaker. So again, for those that are joining new, feel free to just unmute yourself or raise your hand. Then I can give you the floor, and you can just give a question to Gabriele by voice, so you don't have to write it down in the Q&A box. In the meantime, I had a question myself. Here in Delft, there is one company working on this new concept of micro-reactors. It is the company Zero Emission Fuels. Are you aware of them?
Yes, I know the company, but yeah. I have not direct collaboration, yes.
No, I fully agree that thinking about different approaches in that respect regarding scaling up, but also reactor design is a very crucial thing. Because just scaling up, making things bigger is not always the best approach. If you can really optimize a small unit and use economy of scale to drive down the cost, that could also give an interesting option.
Yes, I fully agree, because essentially one, even if I was very brief, I mentioned that process intensification is one of the key elements also together with of electrocatalysis. But of course, if we like to go to a distributed model, we need really to realize this concept of realizing a full transition on a cheap or very small scale. Yeah. And so we need to work on microreactor, we need to work on this kind of technology, we need also to work on separation, on new concept of separation. So we need we need to change our model of production. We cannot just use the old model. And this is the reason why I say that you cannot compare with the classical economic assessment method. You need to include also this possibility to make really a good comparison, also to see the perspective from a company side.
Yeah, I think that was very clear from your talk, is that a radical change is needed in most of our mindsets, and it's not just a different material, it's a completely different way of designing the whole process. Any questions from the audience? Feel free to ask any topic. Another question from my side then, Gabriele. So this morning we had a presentation from Anka from Voltagem about the importance of this collaboration between academia and industry. What is your point of view, or what is the point of view from SunEnergy? Who should be in the lead? Is it the industry? Is it the European Union? Is it, let's say, policymakers? So where is the biggest? Who is the biggest driving force in this setting the new milestones for the?
We have just yesterday interboard a discussion about these topics. I think that this is really very important, because we need to change the model of collaboration between academic. Because up to now, company has their strategy, and if they need they go to selected, let me say, research center or academic to have an answer to their problem. This is not the best way in which we can go, especially when we have a drastic transition in a system. So we need also to explain to the company that a system transition created new opportunities, because of course there is many places for many small companies. But this can be achieved only if there is a very strong collaboration between company and academy on different bases, because it's only sharing together the new vision and expertise which can be achieved the goal. So it's very important, but needed to be refunded in some way, this collaboration.
Another question from my side is, at the University of Delft, we have the Dream Hall, which is a big facility where there are different student teams working together to realize solar boats, solar cars, hydrogen cars, you name it, they are trying to develop it, and they are quite effective. If you look into the example, the Hyperloop competition that Elon Musk started, there are many teams now developing pods for this Hyperloop system. Would it be interesting, maybe from the SunEnergy approach, maybe together with Material Pioneers, to launch a similar, I would say, prize competition for student teams to come up with new microreactors in a similar sense that zero emission fuels is currently doing?
Yes, I think that is a very good idea, because it's really that the effort for the transformation derived from the young people. We need to have new idea, new test. We need to provide them also the possibility that they can test what is an idea and to try to develop. So any of initiative which can stimulate these, let me say, idea from the bottom are very useful, because they create before sensibility on the problem, but also can emerge some very interesting new solution.
Yeah. So last point on that, and then I will give the floor to Wilbert. What I think is a wasted opportunity is that we have this eco marathon competition from Shell, where they are boosting students to develop the most, let's say, energy efficient hydrogen car. But most teams are just, let's say, sourcing the fuel cell from a company. It's just a standard product. I think what we should try to aim is that those students are developing the fuel cell themselves, which is the core component of this electrified car. So I think there's still an enormous opportunity to use the creativity and the access to different technologies that those students have to provide new solutions.
But it is correct, because they need to understand where are the problem, which is not the assembling of different components which are already available, but really to create a new device. So they need to understand, and this can be really the focus of these challenges.
Wilbert.
Hi, Professor Centi. Thank you very much for your presentation. I had more of a, let's say, a general question. So I'm an application specialist at BS Particle, and I've taken a look at a lot of these electrocatalysis groups within the fields in Holland. And what I tend to find is that a lot of the electrocatalysis groups appear to be a subgroup of a group that is classically a heterogeneous catalysis group. You're saying that we need to have this whole transition towards a new paradigm. So do you expect in the future that we'll have more of these independent electrocatalysis groups that aren't being led by a classical heterogeneous catalysis approach? Or do you expect this to still stay the same for quite a while?
Yes, I think that it was in some way obvious that the fact that in some way the support to traditional catalysis was slowing down, and at the same time was emerging this aspect of photo, electro, and other catalysis. So mostly the people from heterogeneous was switching to this area. But really, the aspect is that we need to understand that it is not the application of the same concept. And this was the part of the message that I was trying to say. And for this reason, we need really to develop a group that address electrocatalysis from a creative point of view, which is not simply a transition from heterogeneous catalysis normal, but really creating all the bases. I was quickly mentioned that up to now, often is considered electrocatalysis in presence of electrons. This is not true. We need to have different approach. We need to understand how to handle these very reactive species. how to really match the fact and why, for example, we have a very reactive species, but the rate of electron transfer is still very slow. Mostly of the reaction rate, even at the best in electrocatalysis, are still too much slow. Let me say that turnover number, they are still too low, especially respect to, which means that we need to work at higher overpotential than what we need. And this, of course, is influencing Faraday efficiency. If we can just work at the minimum overpotential, which is necessary due to the fact that we have very, very active sites, even at low overpotential applied, this can be really a breakthrough, but we still don't know how to really make more reactive the electron transfer.
Thanks, Wilbert, and thanks, Gabriele, for the answer.